We're going. Yes, we're recording. All right. So for 4.5, I just want to go over two problems, tying everything together from writing formulas with one variable, and then also how do we find max and mins from there. Okay. So here's an example. Which point on the graph of y equals the square root of x minus 2 is closest to the point 7, 0? Okay, and if you're looking at that and you're not sure where to begin, that's okay, but draw a picture and see if you can kind of label some things and then go from there and make it a little easier. So, a nice sketch of the graph is a good idea. Do you guys remember what this minus 2 does to the square root graph? Moves it to the right 2. Good. So here is y equals square root of x minus 2. That's the picture we're talking about. And then 7, 0, well, that's probably around here somewhere. And what they want to know is what point on this square root curve is closest to 7, 0. So, I mean, I think you guys can see that if I go straight up, that's probably not the smallest distance. Certainly if I go all the way back, that's probably too large. Maybe something like this would be the optimal distance. The only issue, of course, is that we don't know what that point is. That's what we're trying to find. Okay. Now, when you see the words the word closest, do we want a minimum distance or a maximum distance? Minimum. Okay. So we want minimum distance. So in other words, if I have a distance equation, then we could use that distance equation to answer the question. So let's write one. How do I find the distance between x comma y and 7 comma 0? The square root of what? Okay, I'll put that over here. Good, so it's just the distance formula. And let's just kind of simplify that. So we have x squared. Don't forget, if you FOIL out x minus 7, there's a middle term there, so be very careful. And then y minus 0, that's just y. And then square it, that's y squared. Okay. So just like the problems from 4.4, the main problem right now is that we have two letters, we have two variables, we just want one only. Okay. Do we happen to know what y is? Yeah, they told us it's the square root of x minus 2, right? So why don't we go ahead and swap that out. Plug it in for y. You're going to square the square root, and then let's just kind of clean everything up again. So again, I'm showing all the steps here. If you square the square root, you just get x minus 2, right? Right, because if you square the root, then there's no x, it's just a 1. So this is going to be x squared, and then how many x's? Minus 13x, and then 49 minus 2 is 47. Okay, so here is our distance function. Here's our distance formula. Okay, they want, and I always go back to the original question, which point, right, is closest? Well, is there a shortcut or anything that we've learned that could help us find the x? Now's your time to shine. What's the shortcut for? Yep. You could complete the square, but the shortcut would be? Yes, opposite of b over 2a. Good. So we're kind of marrying everything we've talked about into one problem here, right? If I find the opposite of b, that is 13, 2 times what's a? 1. So x is 13 over 2, which is about, well, it's not about, it is 6.5, right? Which kind of makes sense with our picture, right? We said somewhere over here should be the x value, so 6.5 seems reasonable. All right? And now here's where I'm going to kind of, talk a little bit just to make sure you know what to do with this. The only types of questions you're going to be asked are which point, what dimensions, what x and y values, okay? That's all really the same thing. Or the other option, which is find the minimum distance, find the minimum cost, find the maximum whatever, okay? So depending on what they want, that tells you what to do with this x value here, okay? Since I want a point, right? To have a point, I need an x and I need a y value. So where could I plug in 13 over 2 to find the y value? Careful. If I plug it into all the x's here, and I figure it out, that's going to spit out a distance, right? We want a y coordinate. Exactly. Yes, yes, yes. Right here, we know exactly what y is, right? So we're going to plug it into y equals the square root of 13 over 2 minus 2. 2 is the same as 4 over 2, right? So that's 9 over 2. Square root of that. The square root of 9 is 3. Root of 2 is root of 2. And just like I said, I don't care if you leave it this way, but the SAT, ACT people would like for you to rationalize. So 3 root 2 over 2. So there we go. So this answers the question. Okay? The question was what point is closest? We've located it. It's at 6.5, and then whatever 3 root 2 over 2 works out to be. Okay? The other question that I could have asked is not to find the point, but to actually find what is that smallest distance. And then what Nicole said would be what we would do. If I want to know the actual distance, right here where it says distance, that's where you plug it in. You guys see that? So depending on what it asks, dictates where you plug it into. Either the first equation up here or the distance equation, depending on if it wants distance or not. Any questions on that? Yes.
So when you get the new point, try and find the distance, like the cobblestone,
Uh-huh.
would you plug it into just like the regular distance one, or would you plug it into the last one?
I'd plug it into the last one, yes. Because this is the one that's cleaned up and it only depends on x. And since I have x, now I can just square it, multiply it by 13, subtract, add 47, and square root it, and I'm done with it. Any other questions? Okay, one more problem. Okay. So let's say we have a house of some sort. So I'm going to draw a picture as I describe the scenario. And what we want to do is build like a fence in our yard that would look something like this. Okay, so we have a rectangular yard. We need to put some fencing around it. Okay, and here's what we know. We have 200 feet of fencing available. we want to find the maximum area for the rectangular yard. So I'll even use green for grass here. Okay. So your job is to write down any formulas that might help us, right? This 200 feet of fencing, where does the 200 come into play? The perimeter, right, the perimeter. Notice, am I using all four sides here? So, why don't we label this rectangle? Do you want to use X and Y or length and width? Or okay, so let's say that's X and that's Y. The perimeter for this rectangle would be
2x plus 5.
very good. And we happen to know that we have 200 feet to use for that. So I'm just going to replace 200 in for the perimeter. And there's one formula that might help us. Okay? And that's all from this first half of the question. Just knowing that we have 200 feet of fencing available. Now we want to find the max area. So we should probably write down an area formula, right? How would I find the area for this rectangle? Base times height, which is in this case, yes, X times Y. Okay, now we've reached that same point from before. I can't do anything with this yet because it's two variables right now. So what could I do up here that I could maybe use down here?
Divide by 2x.
So we're going to get Y. I don't know if I want to divide by 2x. How would I move if I'm just doing 2x added with Y? There we go. So if we subtract 2x to the other side, we get Y equals 200 minus 2x. And now, instead of x times y, we're going to replace y with 200 minus 2x. Clean this up as much as possible. So, Nikki, do you see the point of why we want to simplify everything, right? And there's our area function, which, again, happens to be quadratic, which, again, you know how to find max and mins for, right? How would I find the correct x value? So the opposite of b in this problem is negative 200. The order is reversed, so don't fall for that. 2 times a is negative 2. So that's 200 divided by 4, which is 50. That sounds reasonable. Okay. And now, again, here's a good time to check for what you want again. The problem at this point is going to take two different directions. I could have asked you to find the dimensions of the rectangle with the largest area, in which case, if I have the x dimension, I could just find the y dimension by plugging in x up here, right? But since I actually want the maximum area, where do I plug in the x here? And yeah, into the area equation. So we're going to take 50, plug it in. I'm going to need your help here. I don't have a calculator. 200 times 50 minus 200 times 50 squared. What's that? Oh, I said it wrong, but I wrote it right. Thank you. 2 times 50 squared. What is it? 5,000. And we are in feet, so we're going to put our units. 5,000 square feet would be the largest area possible here. Just curious, if I did ask you what are the dimensions that give you the largest area, what would I do with the 50 again? If I want the dimensions instead of the actual area, right? What are the dimensions of the rectangle here? X and Y. I have X. Plug it into the Y equation, and then you'd be done. Does that make sense? So depending on what they ask you, right, don't just go crazy plugging 50 in wherever you want. You got to make sure you plug it in to the right spot. Yes. P is perimeter, A is area, and the way we defined it was X was the length dimension and Y was the width dimension. Good. Any other questions?